हेलो, वेलकम टू माय यूट्यूब चैनल। आज के इस वीडियो में हम लोग डिस्कस करेंगे कंप्यूटर एडेड प्रोसेस प्लानिंग विच इज़ आल्सो नोन एज CAPP। So C stands for computer, A means aided, P means process and P means planning. So computer aided process planning. Now first of all we will discuss about the planning function. What exactly the role of planning department in industry. So basically in industry there are different departments like marketing, design, planning, production, quality, service. So these are nothing but different departments, and here we are discussing the planning activity of production department. So every part or product that has to be manufactured in the machine shop of the manufacturing company has to undergo through a series of machining operation in a proper sequence. So suppose any industry is there and it is manufacturing a particular product. So for converting a raw material into a finished product, various manufacturing processes are required. So we have to add the value to that product stage by stage so as to get a finished product. So every product has to go through number of manufacturing processes so as to get a finished product. Then the manufacturing process planning involves determining the proper sequence of manufacturing operations to be carried out so that the part can be produced in the least possible time, making the optimum use of available resources. So now the objective of manufacturing department is to manufacture the product into least possible time. That is the first objective, and second objective is to use the optimum available resources, because today there is a lot of competition in the market, and to survive in the market you have to minimize the cost of your product, and you can minimize the cost of your product by minimizing the cost of resources. So basic objective is to manufacture the product into least possible time and with optimum use of resources. Then to make the proper sequence, the operations are documented on a form known as route sheet. So once the operations are decided for manufacturing the product, then it is listed down over a piece of paper, and that piece of paper is known as route sheet. So basically in process planning activity, you have to write down a process plan, and that process plan is nothing but a sequence of operation. So first of all you have to list down the operations, and then you have to decide the sequence of operation also. Then in the route sheet there is a list of production operations and the machine tools that can carry out these operations on the part or on the assembly. So basically the route sheet consists of various operations that has to be carried out over the product, and then the various machines which are required for carrying out those operations. Then the various cutting tools which are required over that machine tool. Then from process planning, the manufacturing supervisor has to determine the appropriate cutting conditions for the machining operation, ensuring that there is a least wastage of material. So after listing down the entire operations, then listing down the various machines required, then the supervisor has to decide the various cutting conditions like cutting speed, feed, depth of cut, so as there should be less wastage of material. After that, then the supervisor also sets the appropriate time for each machining operation so that the part can be manufactured within the stipulated time, ensuring the optimum productivity. So after deciding operation, machine, then the cutting conditions, cutting tool, then he has to decide the time required for a particular operation, because the role of supervisor or the role of manufacturing department is to manufacture the product within the stipulated time. So he will decide the time for each operation, and he is responsible for manufacturing the product within that specified time. Now we will discuss traditional manufacturing process planning. So up to this point, what we have discussed? We have discussed the planning activity. Now we will discuss the traditional manufacturing process planning, because we can classify the process planning into two types. The first one is manual process planning and the second one is computer aided process planning. So before starting the computer process planning, first we will discuss how the process planning is done manually. So all the three tasks, that is process planning, determining cutting condition and setting the time standards, are the routine ones for the production engineer and mostly involves the clerical task. So merely by looking at the drawing, the production engineer can decide the number of operations required, then the cutting conditions like cutting speed, feed, depth of cut, various cutting tools, fixtures, those are required, and then the time required. So it is a routine task and it is a clerical task. Simply he has to look the drawing and then he has to list down those operations. Among the different companies and the industries, there are a lot of variations in the format of the root sheets and the detail found on it. So as the company changes, you may find different process sheets. There may be different columns over that process sheet. So it is not fixed kind of activity because it is a manual activity. So it depends on the type of product, or it depends on the type of industry, or it depends upon the type of supervisor. He will decide what are the different columns that are required over the process sheet. So it is not a fixed activity when it is done manual. The whole process of planning is done in different way in different companies. So as the company changes, you may find different type of process plan. It depends on the engineer who is working on it. He will decide the parameters which he wanted over that process plan. In some of the cases, the manufacturing engineer gives the detailed list of steps of the machining operation and also mentions the work center on which the operation has to be carried out. So in few companies, the manufacturing engineer will decide the various steps of machining operation and also he will mention the machine over which you have to process that part. It is the duty of manufacturing engineer within a company to write the process plan for the new part design to be manufactured in the machine shop. So basically, the manufacturing engineer or the production engineer is responsible for preparing the process plan. The process planning task is usually too much dependent on the experience and the judgment of the engineer working in the production shop since year. So basically, the process plan depends on the experience and the judgment of the production engineer. As your experience increases, you may write a perfect or you may write a good process plan. So basically, the process planning activity depends on the experience that you have and the judgmental power you have. Until recently, the whole process planning tasks were being done manually. However, the individual engineer have their own opinions about what constitute the best routine for the manufacturing of the job. So basically, as the process planning is done manually, it depends on the individual judgment. He will decide the type of sequence because the sequence is not fixed. You can alter the operations also. So it depends on the engineer who is working there and his experience. On the basis of his experience, he will decide the sequence of operation. Due to this, there are the differences in the sequence of machining operation. As you can alter the sequence, so there may be different sequences you may find for a similar product. But now the computers are being used for the manufacturing planning task. But nowadays, this activity is done by computer and hence you will get a fixed process plan for a particular part. The use of computer for the process planning enables removing a number of problems associated with the manual processes. So as you are using a computer, you can remove a number of problems which are associated with manual process because the process will get standardized. So here on the screen, you can see an example of process plan. This is nothing but a route sheet or a process plan for a particular part. So at the top you can see the part number. The part number is 031393. It depends on the part. So the different parts may have different part number. Then the part name, that is nothing but housing. So here we are writing a process plan for a particular housing. Then you can see revision 2. That means it is a second process plan. Earlier there was a different process plan. Some revisions are made. So this is second revision. Then page 1 of 2. Now this process plan is of two pages and I am showing here first page. Then the material 416 stainless steel, that you have to mention. Then the size of the part. So the size is, diameter is 2 inch and 5 inch long. So one cylindrical job you have whose diameter is 2 inches and the length is 5 inches. The planner is MPG. MPG is nothing but the initial of that process planner and the date is mentioned. Now you can see a table. The very first column, that is nothing but operation. The operations are 10, 20, 30, 40, 50. You can write 1, 2, 3, 4. You can write 5, 10, 15, 20, 25. Okay. So here 10, 20, 30, 40, 50. Likewise it is written. Suppose you want to add any operation. So after 10 you can write 11. You can write 12. That is why the numbers are taken like 10, 20, 30, 40, 50. So intentionally few space is provided for writing the operations which may be required. Okay. After that the second column is operation. Then the third column is department. Fourth column is machine. Fifth column is tooling or the gauges. Sixth one is setup time. And the seventh one is cycle time. Okay. These are some columns which are required. You may find different columns also in a different process plan. It depends on the manufacturing engineer. Okay. So the very first operation, that is facing. After that rough and finish turn to 1.473 plus minus 0.003 diameter multiplied by 1.250 plus minus 0.003. Okay. So first of all you have to carry out a roughing operation. Then the diameter is mentioned, that is 1.473 and the tolerance is given plus minus 0.003. That means on plus side 0.003 and on minus side 0.003. So the complete tolerance is 0.006. Okay. After that there is a shoulder. Its diameter is mentioned. Then again there are 3 grooves. Its width is given. So in the second column you have to mention the operation. Then you have to reverse the job and again you have to perform the facing, roughing and turning operation. Okay. Then the third operation, that is nothing but drilling as well as milling. The fourth operation is milling and fifth operation is also milling. Okay. Then as the first operation is roughing, that will be done on lathe machine. Second operation again turning, so it will be done on lathe machine, so lathe department. Third operation is drilling and reaming, so it will be done in drilling department. Fourth and fifth operation is milling, so it will be done in milling department. Then you have to mention the machine numbers. So the machine numbers like 325, 114, 240, these are nothing but different machine numbers. After that you have to mention after that you have to mention the various tools. After that you have to mention the various tools or the gauges required. Then the setup time. So you have to set the job over the machine. So setup time is mentioned. So for the first operation setup time is 1 hour. Second operation 0.5 hours. For third, fourth and fifth operation it is 0.3 hours. After that the time required, that is cycle time. So for first operation the cycle time is 8.22 minutes. So for carrying out the first operation you will require 8.22 minutes. For the second operation 3.10 minute, 50 minute. For fourth it is 1.75 minute and for fifth it is 1.60 minute. So this is nothing but an example of process plan. Here what you have to see, The process plan consists of various columns, compulsorily the operations, then the department, then machine number, then the various tools or the gauges required. After that, setup time for setting the job over the machine and the time required for carrying out that operation. So this is the best example of the process plan. Now we will discuss computer aided process planning. Earlier we have discussed manual process planning and now we are discussing computer aided process planning. So the use of computer for process planning is called as computer aided process planning or simply CAPP. So if you are using computer for the process planning activity, then it is known as computer aided process planning. With CAPP, the routine clerical tasks of the manufacturing engineers are reduced so they can invest their time in more productive tasks. Okay. Further, with the computer, it becomes easier to generate the production routines that are rational and consistent without depending on the experience or the judgment of the individual. So basically, with the computer, you can generate the process plan very easily. Suppose your manufacturing engineer leaves the company. In that case, you have to recruit the new employee. And if he do not have a sufficient experience, then he cannot write the process plan efficiently. But if you have a software for generating the process plan, then simply you have to enter the details. The computer will give a proper process plan for the particular part. There are two types of approaches for computer-aided process planning. The very first, that is retrieval type of CAPP, and second one is generative CAPP. So we can broadly classify computer-aided process planning into two types. The first one is retrieval process planning and the second one is generative process planning. So now we will discuss retrieval type of process planning. So as the name indicates, we have to retrieve the process plan from the computer for a particular part. Okay. So in the retrieval type of CAPP, the various parts to be manufactured are classified, given codes and grouped within certain families. So for understanding the retrieval type of process planning, you have to understand the group technology. So group technology is a manufacturing philosophy in which the similar parts are identified and grouped together. The grouping of those parts is known as part family, and for the particular part family, one code is assigned with the help of part classification and coding system. So you will have different chart. By referring those chart, you have to generate a particular part number for a particular part. Okay, that concept is known as group technology. Within each part family, standard process plan is established which is stored in the computer. Once the code is generated for a particular part, after that you have to write a process plan for a particular part and then you have to store that process plan inside the computer. This process plan is also used for new parts that come under the same family. Once the process plans are stored inside the computer for a different part family, after that if you receive a new part, then you have to compare that part with the existing part family. Okay, and then once its code is decided, that code you have to enter inside the computer and you will get a ready-made process plan from the computer. That is why it is known as retrieval type of process planning. Then the system developed in such a way that it is easier to retrieve the process plan for the new work part. Once the particular code is decided for a particular part, that code you have to enter inside the system. Then you will get a process plan for that particular part. The whole process plan documents the operation as well as the sequence of operation on a different machine. The retrieval CAPP system offers lot of flexibility as one can do lot of editing and changes as per requirement. So first of all, you have to generate the part for a particular, you have to generate the code for a particular part. That code you have to enter inside the system. You will get a ready-made process plan from the system, and then suppose if you want to change If you want to edit that process plan, you can edit that process plan, and again you can save that process plan so that you can again retrieve it. So this diagram shows an architecture of retrieval type of process planning. So the part description will be there on the basis of part description. So part description is nothing but its geometrical parameter, its manufacturing parameter. On the basis of its geometrical and manufacturing parameter, you will generate a group technology code, and that you will enter inside the system. So that system will consist of various process plans. Okay, and whatever the process plan which is related with that GT code, that is get retrieved. Okay, then after retrieving that process plan, you can edit that process plan, and again you will store that new process plan in a master plan database, so that again you can retrieve it. So this is nothing but a retrieval process planning. Now we will discuss generative type of process planning. So in generative process planning, in generative process planning, new plan is made automatically from the scratch for each part using the computers without involving human assistance. So basically in the retrieval process planning, you have to decide the code for a particular part, and that code you have to enter inside the system. Then you will get a particular process plan for that part. Whereas in generative process planning, you need not to generate any kind of code. Simply you have to give details of that part to the system. Okay, so the process plan is generated from the scratch by using computers without involving human assistance. So that is the major difference in between variant process planning and generative process planning. Then the computer program uses a set of algorithms that enables it to take a number of technical and logical decisions to attain the optimum final manufacturing process plan. So the software will consist of various algorithms. Those algorithms will run behind the screen, and after that you will get an optimum type of process plan from the computer. One has to give certain inputs to the system, like detailed description of the part to be manufactured. In variant process planning, you have to give a GT code to the system, whereas in generative process planning, you have to describe the part. Then this CAPP system synthesizes the design of the optimum process sequence based on the analysis of the part geometry, material, and other relevant parameter. Once the details of the part is given, then the programming is done and you will get a final process plan. So this diagram shows an architecture of generative process planning. So it consists of manufacturing database, which will have machine tool, then cutting tool, jigs and fixture data, and material data. Okay, so part descriptive data. So you have to describe the part to the system. So you will describe the part in terms of its geometry. Then the software will give output in form of process plan, and new process plan will be generated. So this is nothing but an architecture of generative process planning. Now we will discuss the benefits of computer aided process planning. So the very first benefit of CAPP is process rationalization. As you are using computer, so there will be a standard process plan for a particular part. Okay, in manual process planning, it depends on the experience and judgment. Whereas in computer process planning, you will get a standard and efficient process plan. That is the first benefit, process rationalization. Second benefit, higher productivity of the process planner. As you are using computer, so simply he has to generate the code and enter the code. He will get the process plan. Or he has to describe the geometry. He will get the process plan. So the remaining time he can use for different operation, and ultimately you can increase the productivity of your manufacturing engineer. The third one, faster planning. So as you are using computers, so you will get a fast process plan from the computer. It will require very less time. Whereas in manual process, a time is required for generate the process plan. Then good visibility, as the process plan, you are getting the process plan from the computer, so it is neat, clean, and it will be clear. If it is done manually, then the manufacturing engineer has to write the process plan, then it will be difficult for the worker to understand it, because it depends on the handwriting of that particular production engineer. And the very last advantage, that is operate with other software. So you can integrate the computer aided process planning with the design softwares, with the manufacturing software, so you will get some other benefits also. That is nothing but the integration benefits. So these are nothing but some benefits of computer aided process planning. Thank you so much for watching my lecture. Thank you.